learning equivalent fractions and how to solve for the missing number. And there's always going to be some kind of variable, and it doesn't matter where the variable is, it's the same process. And here's how you do it. So if they're equivalent, that means this fraction and this fraction are exactly the same, just one's smaller and one's bigger. So I say to myself, what times 5 gives me 15? And that would be 3. And then I do the same thing up here. I multiply by 3. So 4 times 3 is 12. So x equals 12 here. And you can prove that by doing 12/15ths, and then you divide it by a common number, which would be 3. And you would get 4/5. So you could kind of check your work and figure out the equivalent fraction of reducing it. Let's look at another one. All right. 8 over 9 equals 24 over y. What is y? You do the same thing. What times 8 is 24? And that's 3. Now, whatever you multiply the top or bottom by, you do it by the same number on the top or bottom. So 9 times 3 is 27. So y equals 27. Now, you might get a problem where you're not multiplying, you're dividing, kind of like reducing. So what divided by 36 gives you 12? And let me clean this up a little bit. What 36 divided by what gives you 12? The answer is 3. And so I divide the bottom one by 3. Now, if I can't divide the bottom one by 3, I'd have to choose a different number. But I can't, because 36 divided by 3 is 12. 48 divided by 3, and you can just simply do a long division problem if you don't know that. And it's 16. So W equals 16. All right, let's look at one more. All right, number 4 here, same thing, it's a division problem. I look at what I have, 63, 9. I was like, okay, what can I divide 63 by to get 9? And if I divide by 7, I get 9. So I divide this one by 7. And 42 divided by 7 is 6. So in this problem, M equals 6.